Dear students, welcome to this video number 5 on simultaneous fault. In this video, we shall continue numerical on two-port network. So in video number 3 and 4, we have solved some numericals on Z parameters and Y parameters. Now we shall continue with some more numericals on Z and Y parameters, which are most probably asked questions in the university exams. So now I will take some examples which are asked in the university exams. So before taking the examples, let us have some understanding of our reference networks of Z parameters and Y parameters. So in previous videos also I explained. So for Z parameters, now suppose uh, this is our reference network. I call it as a reference network because by using these the Z parameters of this reference network, I can find out the Z parameters of some other circuits. So let us first understand this reference network uh, for Z parameters. Suppose this is Z1 ohm, this is Z2 ohm, and this is uh, say Z3. Now, what is Z parameters for this? Already I told in the previous class the Z parameters for this network. Now Z11, that is the first element of this Z matrix. So it will be Z1 plus Z2. That is this resistor value or impedance value plus this impedance value will give you Z11. Then minus Z2, Z12 value will be Z2 and not minus your plus. It is simply Z2, which is common for the two loops. Then Z21 will be also Z21 and Z22 will be Z2 plus Z3. So this is Z11 value. So how you find Z11? Z11 is this resistor plus this resistor. This is Z12, which is the value of this impedance Z2, and Z21, this is Z21, which is equal to Z2 value again, and this is Z22, which is equal to Z2 plus Z3. Okay, so now this network I will take it as reference, and I know how to find Z parameter for this circuit by just simply inspection. Okay, now I will take a reference network. Suppose one more point I forgot to tell. Now, uh, now we can find the Y parameters for this circuit for this by taking the inverse of this Z parameter matrix. Y equal to Z inverse. Okay. Uh, Now I will take a reference network for Y parameters. So let this be the reference network. Oh, let this value be y1. I am taking it in mo now. y1, y2, and y3 mo. Now I am finding y parameters. Y parameters y11, y12, y21, y22. Now what will be the value of y11? y11 will be y1 plus y2, the total admittance connected to this port. So it is y1 plus y2. Then y12 will be the admittance between connected between port 1 and 2, that is y2, and deliberately we have to take minus sign to this. Similarly, y21, it is admittance between port 2 and 1, so it is again y2 and put minus sign to that. Y22, it is a total admittance, so this is y3. The total admittance connected to port 2, it is y2 plus y3. So y2 plus y3. So we'll get, this is how we can find the y parameter for this reference network. Now how we can find z parameter to these? Z parameters can be find out by taking the inverse of y parameter matrix. So having the knowledge of this reference network for z parameters and y parameters, now let us take some numerical from the SUT, university question papers. So I will take the first example over here. So find Z parameters. Now there are sub questions in it. So I will take the first sub question, that is I will take this. Okay. Now this value is given as Z. Okay, now we want to find out the Z parameters of this circuit. This is similar, this is like this is the equivalent circuit of a transmission line between two ports. So here we can say that transmission line, it is modeled by assuming short transmission line simply by impedance. No charging, line charging capacitance is not included. So now how to find Z parameters for this? Now what I will do, I will try to convert this. Even I can find, Z parameters or Y parameters by writing analytical equations, KVL or KCL, but I will use this approach. So I will try to convert this network to a reference network. So in the reference network, I will take this, I will take this. Okay, so this is Z value, and I will add one impedance over here and one impedance over here, and this value I will call it as, say, Z. I will call it as uh, you know okay, I will call it as admittance y1 and this as admittance y3. In the previous network, I think we have taken y1, y2, y3. Yeah, we have taken, we can see here, we have taken this value as y1, y2, and y3. So in the same way, I will take these values as y1. Here I will take it as y2, y2. Now because this value is given z impedance, so admittance will be 1 by z, 1 by z. So now what are the values? Now what is y1 value? What will be the y1 value? Now y1 value, we have to understand that this is an open circuit over here. Actually, you can see here I don't have any resistor here, when it is an open circuit, when it is an open circuit, I will write here, when it is an open circuit, we can say the impedance is infinity. Okay, so what will be the admittance? Admittance will be 1 by Z, so it will be 0 value. So y1 value, it will be 0. What do you mean by y1 0? Y1 admittance 0 means it is as good as open circuit. Similarly, here also we want open circuit. You can see here at this point there is no resistor, but we have included a resistor, and the value of that resistor should be such that it should behave like open circuit. So the impedance will be again infinity here, and y3 value will be also 0. So now we can find y parameters to this circuit. Y parameters. So y parameters is equal to, already we see that what is y1, that is y11, y12, y21, y22. Now this is equal to, what is y11? Y11 is y1 plus y2. So y2, y1 is 0 value. So this value will be, it is simply 1 by z, 1 by z. Then y12 value, it is equal to y2. Y2 value is 1 by z, and we can put minus sign to that. So it is minus 1 by z. Then y21 value, it is the admittance between port 1 and 2. So it is again 1 by z and minus sign. And then y22 value, y22 value is y2 plus y3, y2 plus y3, but y3 is 0, so it is simply 1 by z. So we get the impedance, so we get the y parameters as 1 by z minus 1 by z minus 1 by z, and here we will have 1 by z. Now how you get, but we require, now we find out y parameters, but we require z parameters. Now this, this question you can write it like, find z and y parameters. I will do both things over here in one problem only. Suppose if they ask, z parameters, if they ask z parameters, then you first find y parameters and take inverse. But if they ask you y parameters for this network, then there is no issue. We first we get this z parameter like this. Okay. Now if they ask z parameters, then we can take the inverse of admittance matrix. Now how to find the inverse of the matrix? So already I told you, suppose if I have a matrix A with A, B, C, D, then uh, A inverse, we can find it first in the numerator. We have to find out the transpose of a cofactor matrix. So the transpose of the cofactor matrix will be D. You have to interchange this principal diagonal. So dA, and then you can put to off diagonal, we can put negative side, divided by the determinant of this matrix. The determinant of this matrix is AD minus BC. Okay, so using this same approach, I will find the inverse of this matrix. So this is my now Y matrix. So how do I get? First, I will write the, uh, now I will interchange this. So it will be remain same 1 by Z. Now it will be remain same, and to this off diagonal element I have to put 1 by z and minus to that. So minus and minus will get plus. So here also we will have 1 by z divided by the determinant of this matter. Determinant is 1 by z. This is 1 by z into 1 by z. So it will be 1 by z square minus, then this into this, minus, so minus minus get plus, so it is 1 by z square. 1 by z square minus 1 by z square, this will lead to 0. So ultimately you will have 1 by z, 1 by z, 1 by z, 1 by z divided by 0. So already we know anything divided by 0 is infinity. So all the element of this matrix will become infinity. All the elements will become infinity. So this is your y, z parameters for this network. Okay. So in the same network, for the same network, I have find out z parameters and y parameters in one problem only. So they ask either of two, z parameters or y parameters. Okay. Now I'll take next example here. Uh, okay. Now find z and y parameters. Okay. Find z and y parameters. So I will take a circuit now. Suppose this is z. Okay. Now what I will do, I will first, oh sorry, I have taken this wrong circuit. 1 minute. Change it. So this is like this. I will take this resistor over here. This is Z. Okay, ZO. This. Okay. Okay. Now what I will do first, I will convert it into my reference network. So what is my reference network? Now I will take the reference network of Z parameters. Okay. So now here they are given Z. I think we have taken this as Z1. This I will take it as Z2 ohm and this as Z3. Now what is Z1 value here? Now here Z1 value will be, now we can see here there is no resistor here. So it is like in short. So now we can assume this Z1 equal to 0. It is as good as short circuit. So I will take this Z1 equal to 0 value. So it is as good as short circuit. And similarly here also I don't have any resistor, but I have put some resistor as the impedance Z3, and this value also I will take it as 0. And Z2 is equal to Z ohm. Already they have given, so that's not an issue. Now let us find Z parameters to this. So Z parameters equal to, we know that it's Z11, Z12, Z21 and Z22. Now what is Z11 value? Z11 value is Z1 plus Z2. Z2 value is Z2 only, that is common between loop 1 and 2. Z21 is Z2 value. Z22 is Z2 plus Z3. So we can have this value as here. Now what is Z1 plus Z2? Z1 is 0. So it is simply Z. This Z2 it is Z. Okay, Z2 is also Z. Z2 plus that is also Z. So we get this Z parameters. Now what will be Y parameters? Suppose if they ask Z parameters, then we can ended up to this. But suppose if they ask Y parameters, then you first find Z parameters, then find Y parameters by taking the inverse of this matrix. So how to take inverse? Now already in the previous I told, interchange this is a shortcut method to interchange this of diagonal element. So even if you interchange, you will get same thing, and then you have to put negative sign to this off diagonal. So it will be minus z, and this will be minus z divided by the determinant. Determinant, it will be z square minus z square, and this will be 0 and anything by 0 it will be infinity. So we will have infinity, infinity, and infinity, and infinity. So all the parameters, they will be infinity. So this is how we can find the z and y parameters for this circuit. Now let us take the next example. These are all asked in the university. So either they will ask z or y. So but I am doing both. Okay. Now let us find z and y parameters for the circuit. It is given something like this. Okay. Now what I will do, I will you can convert it to one of the reference of z parameter or y parameter. Okay, I will take this z parameters. I will take z parameters. Okay, so a resistor over here, and there is one more resistor over here, and there is one more resistor over here. Okay, now Z1, Z2, and Z3. Now what should be the value of Z1? Now we can see here, suppose this is my midpoint over here. Now here I don't have any resistor in this part, but I have included a resistor Z1 or impedance, and now this value should be 0, means it is as good as short circuit. Similarly here on this part also there is no impedance, but I have included Z3, but this value should be 0, indicating it as a short circuit. And between this here we have included resistor Z2, impedance Z2, and the value of this impedance should be infinity. Why it is infinity? Because it is as good as an open circuit. We don't have resistor. Now we can find Z parameters to this. Okay, so very simple. Z11, Z12, Z21, Z22. Okay. Now what is Z11? Z11 is Z1 plus Z2. This is Z2. This is Z2. This is Z2 plus Z3. So what is Z1 plus Z2? Z1 plus Z2, Z1 plus Z2. Now 0 plus infinity, because this is 0 and plus infinity. 0 plus infinity is infinity. It's infinity is infinity. You can write infinity. And Z2 value is already the infinity. This is infinity. And Z2 plus this is also infinity. 0 plus it is infinity. Now how we can find y parameters? How we can find y parameters? So y parameters, so it goes into indeterminate form, something like that. Because if you take the inverse of this matrix, then it will become, so it will be in the indeterminate form. Actually, it will be indeterminate form. In, sorry, indeterminate form. Okay. Now let us go to next example. Can have okay. I will just try it out. Whether can I remove this indeterminate form? Because in the exam I cannot write this in this one. I will use some different approach for this. Okay. Now I will try to convert this network to the reference network of, let us convert it into reference network of uh, y parameter. So this is okay. So this is say y1, y2 and y3. Now y1 value you can see here, it is open circuit. So when it is open circuit, this value will be 0. Impedance will be infinity, admittance will be 0, and here it is short circuit. So y2 will be infinity, and because it is short circuit, and y3 will be again 0. So what will be y parameters to this? Y parameters, so it will be equal to y11, y12, y21, y22. Now we can have, what is y11? Y11 is y1 plus y2. Here we will have y2 minus, y2 minus, and we will have y2 plus y3. Now what is y1 plus y2? Y1 plus y2, 0 plus infinity is infinity. Okay, so this is 0 plus infinity is infinity. Y2 is infinity, so it is negative of that, minus infinity. And here also you will have minus infinity, and y2 it will be plus infinity. Okay, now if you know if you go with that approach, like if you use this formula y equal to z inverse, then we will end up to indeterminate form. So we will discard that approach, and we can use this approach to find the y parameters. Okay, now let us go to next circuit, the last circuit in this example. So find Z and Y parameters. So for the circuit, so they have given this circuit something like this. This is Z. They are given the Z ohm. This is also Z ohm. Now let us convert it into our standard form of uh, this is Y1. I'll convert into the reference network of Y parameter, and here we have Y2, and then we have here y3. Now y1 it is equal to, here we have given impedance. So what is admittance? It is 1 by z. So y1 value will be 1 by z. Y2 value, you can see here it is open circuit. When it is open circuit, we know that when it is open circuit, the impedance is infinity. So what is admittance? Admittance will be 0. 1 by infinity is 0. So this will be 0. And y3 admittance, here we are given z impedance. So admittance will be 1 by z. So what is y parameter? What is y parameter? So y1 is equal to, y is equal to, we have y11, y12, y21, y22. Now what is y11? Y11 is y1 plus y2 minus y2 minus y2, y2 plus y3. So what is y1 plus y2? Y1 plus y2. So you can see here now 1 by z plus 0. So it will be 1 by z. Y2 it is 0. So you can put a 0, and here y2 value is again 0, and here we will have 1 by z. So this is how we can find this these z y parameters. Now if you can try how we can find z parameters. You take y inverse. So y inverse, if you try to do like this, so it will be interchange of this, then 1 by z, and 0 and 0. If you put negative sign to off diagonal, doesn't change, and divided by determinant. So it is 1 by z square minus 0, so it doesn't matter. and you will have this, this is 1 by z, divide by 1 by z square. So it will be z square by 1, and here it will be 0, nothing found, this 0, and this is again 1 by z into z square. So this will be z 0, 0, and this will be z. Okay. Now, even if you can find z parameters by converting, no, not possible. You cannot convert this network to the reference network as z parameters. Okay, so we can use this approach to find y and z parameters. So in this video, it is up to this only. We will continue in the next video. Thank you very much.